day 2, sorry. 6-2 inverse functions, day 2. I know, that's funny, right? We were talking at lunch yesterday, and Mr. Metz said, sometimes we get off subject so much in my class that we don't even get to the objective. So then I was talking about what we were talking about, and I said, I think tomorrow on my objective I'm going to say we talked about Breaking Bad.
I was with Metz.
I enjoyed Mr. Metz. He's a funny guy.
I wasn't laughing at anything you said, but I just kind of behind.
You just read the Breaking Bad part. All right. So graph f of x equals x plus 2 and g of x equals x minus 2 on the same graph. I hope with all my heart that you can graph these two functions. Boys, do I need to separate you back there?
Yes.
No. Right? A y-intercept of 2, a slope of 1. This would be x plus 2. X minus 2 would be a y-intercept of negative 2 and also a slope of 1. They're kind of silly ones to graph, but these are inverse functions. Do you remember anything about the graphs of inverse functions? Not all inverse functions are parallel. These happen to be. What did we talk about yesterday? What does it mean to have an inverse function? Like, what does it mean, like the definition of an inverse function? What did you do on like the ones on the homework yesterday when it said find the inverse and they gave you points? What'd you do? You flipped the points, which means if you graph f of x, and if this happens to be its inverse, what should happen is every point should be flipped around, right? So we won't do all of these, but if this is the point 0, 2, what point has to be on the inverse? And it is, right? Well, something else that's true about this is all functions and their inverses will be symmetric about the line y equals x, which is this line right here, which works out great when it looks like this line, but we'll look at something that doesn't like that. So this is the line y equals x. So if you have a function, if you flip it over that line, that will always be the function's inverse, because when it's symmetric about the line y equals x, it means the x and the y switch places. I think I wrote that stuff here. F and G are inverses. What do you see? We already talked about that. Here's what you should see. The graph of a one-to-one function, f, and its inverse, f inverse, will always be symmetric to the line y equals x. Which means part of your homework today, they give you a graph with with f graphed, and they want you to flip it over that y equals x line. And maybe we'll practice one of those to see how awesome that graph thing skills are. Which means when you're graphing today, you could just graph both functions, or you could just graph one and reflect it, or graph one and flip all the points. And we're going to do that in a minute as well. And we'll do one that's not just a straight line, so that you won't see, like you'll see that they're not always parallel lines. Good news, you don't have to graph those fraction ones, the rational ones. That's good, right? Right. We don't want to do that again. So what about this? And this is what it looks like in your homework. If you look at the homework from yesterday, there's some graphs like this. It says the graph of f of x is given, graph the inverse of the function. And some of them, they actually give you points, and you can just flip the points over or switch them around. But I'm hoping that maybe we can see the geometric side of it here. And in your book, they do this as well. they put that line y equals x there to try to help you see flipping it over that line. So I'll give you a minute to kind of sketch this out. I should have printed these off for you. That would have been so nice, wouldn't it?
Well, I don't know. I don't know what it is. When I get to the weird
I agree. I think it's more like a little rational graph or exponential graph. I don't think it crosses. I think it goes like this if it kept going. Like it's an asymptote. But you don't have to do that. You can just do the little section that I did. Anybody want to tell me what this looks like? Want to just come up here and draw it? Well, I wonder if I could flip this. Let's see if I have a fancy little button on here. Flip. Left, right. Oh my goodness, that's not right.
Can't you just take the green thing and flip it?
I'm just going to draw it. You could say that this crosses at about 2, 0, which means this one should cross, 0, 2, which means this one should cross at about 2, 0, right? I usually try to get at least 1 point maybe. But then it should flip over, which means this should now be going down, right? And this side that's going up should now be going out like this. So roughly sketching this, I think it should go down like this and like this. That's not bad, right? That's the idea. When we graph exponential and log functions later in this chapter, that's exactly what we just did. This is an exponential function, and when you do its inverse, it's a log function, and that's what it looks like. Who knew? It's close enough, right? All right, you okay with that? The other big thing is, can you write the inverse of a function? And there's just steps for this. And again, it goes back to the basic fact that inverses mean the x and the y switch places, or the domain and the range switch. So if you're going to find the inverse of a function, these are the steps that you should do. These are the steps I give in Algebra 2, which means maybe you don't need all 4 of these steps. But remember that f of x is the same as y. So my first step is rewrite it. Instead of f of x, use y. And then the big step, how do you find an inverse, is step number 2. To find a function's inverse, you have to switch the x and the y. You have to switch the domain and the range. So you have to rewrite that problem and switch x and y around. Then you just have to do the algebra. Solve back for y. We like to get y by itself. And then we replace y with the symbol for f inverse. So it says 4 steps, but I feel like that's not really that many steps to do. Like the key idea is switch x and y. So find the inverse of the function and then graph both the function and its inverse on the same graph. So let's do 1 or 2 of these, and then we'll do a fraction one that we don't have to graph, and then I'll be done. And again, we'll start off nice with a nice linear one, and then we'll do some that aren't so linear. If you're caught up with it or not with what I'm writing here. I don't even know. I went to bed after 11. He got up at 12. He got up at 2. He got up at 3. He also woke back up at 6:30. My husband's alarm goes off at 4:40. My alarm goes off at 5:20. We work at 6. It's like an hour drive. very much like the honor system. Like they just like make their timesheet up at the end of the week. So like if he was 10 minutes late, he could just stay 10 minutes over, or just not even write it, because it's just like they just write, like they don't clock in and out. Like they just write down their times. Isn't that weird? I feel like they trust them. They trust them too much. But he doesn't. He doesn't really lie about it. But he works with another guy who doesn't come in. He's supposed to be there at 6 every day, and he doesn't come in until 7:30 every day. But he still leaves at the same time and still gets paid. So, and they don't want to like rat him out. So, yeah, it's just the honor system.
We have to write ours down when we get there and then people leave.
Yeah. So find the inverse. So when you're finding the inverse, if you can do this all in one step, do it all in one step. But this is the same as y. So this is what I mean by step 1, replace f of x with y. Step 2, switch x and y. You can do that all in one step, right? Like you could automatically say that this is the same as saying x equals 1 minus 3y. Now you just gotta, can you do the algebra? Can you solve y correctly? Subtract 1. I'm going to come up here and say that's x minus 1 equals negative 3y. Divide by negative 3. And you have to graph this, so it's up to you on how you want to do this. This is linear, so I'm going to divide individually by negative 3 so I can think about slope-intercept form. So I would get y equals negative 1/3 x plus 1/3. And then you want to use the right notation. So that's why my step 4 is replace this back with f inverse. You did this in algebra 2. We did it in pre-cal last year. If you took pre-cal, that's how you find the inverse. If you graph it, you should see that it's reflective in the y equals x. So that's a nice way to check it. Or you could just graph 1 and then flip the points over, and that'll work too. So graph both of those if you haven't already. Let's see here. Make your own graph. It makes it not reflect so nicely, maybe, but some people freak out about graphing fractions, right? Are you one of those people? If you graph this one, that has a y-intercept of 1, a slope of negative 3. That's f of x. If you don't want to graph negative 1/3 x plus 1/3, because you don't want to deal with graphing 1/3, you can just flip all those points you just graphed. You agree with me on that statement? The definition of an inverse, is that if you flip these points around that you just graphed, that has to be the inverse. Yes? So that's okay. You could do that. You also could just kind of roughly guess where 1/3 is. 1/3 would be about, I'm going to do it in a different color. Maybe like right here. So if I go down 1 over 3, down 1, I want to go up 1, back 3. Does that work? No? Yes? Maybe? And here's not so bad, right? Maybe, hopefully. Let's do one that's not one. You're okay with that. Stop me if I'm going too fast. Sometimes they're going to give you something like this. And I remember in pre-calculus when we do this every year in like chapter 2 or whatever chapter we do it in, people always say, what does that mean? What's that x 9, what kind of graph is that going to be? A parabola. Does a parabola pass the horizontal line test? No, it fails, which means the only way that a parabola can have an inverse that's a function is if they restrict the domain. So if you see a problem like this, and then after it there's some restriction on x, that means when you find the inverse, you can only graph it for these values, because otherwise it's not going to be a function. Also, you have to just be able to undo this, and I just want to remind us that we could do this the other way. Come on, you got to stay awake. If I'm boring you that much, then I don't know what to tell you. Sit up, keep your eyes open. I'm an idiot. What am I supposed to do next? Switch x and y, right? So x goes here. That would be y squared plus 9. Sorry. I'm just annoyed at children sleeping in my class. And if we want to get y by itself, you're still going to undo its addition and subtraction. So you're going to get x minus 9 equals y squared. How are you going to get rid of that squared? Square root it. If you have a cube in your problem, you're going to cube root it, right? So you have to undo what's there. Normally, when we square root both sides of an equation, we have to put plus or minus because it's plus or minus. But because they're telling us that we're only doing greater than or equal to 0, we're only going to take the plus side of that. So that's why we're going to say that our inverse is just the positive square root of x minus 9. That's how you get something that doesn't pass the horizontal line test to have an inverse. So I would say that the inverse is the square root of x minus 9. Now this was going to be kind of ugly to graph just because of the fact that it's 9. I should have picked a better number than this. Because what does a parabola look like? It has a plus 9 out here. What's that mean? It's moved how? It's moved up 9, so it's just annoying because it means our graph needs to go up to 9. But just don't make any negatives is what I say. So if I was going to make my graph, I'm going to make it have not much negative y and lots of positive y. I wish I had that on my homework. I can just move stuff around. If you remember what square root graphs look like, then you can just graph it like that. But I want to use the idea of inverse to help you graph on this one. If I'm graphing x squared plus 9, but only when x is greater than or equal to 0, that means I'm not going to graph the negative side of that parabola, yes? I'm only going to graph the positive side. So that means it's going to go up 9. And then you should know for a parabola, if you go over 1, you go up 1. And that's okay. I'm just going to graph that one little side of that. Because now that passes the horizontal line test. That's why they restrict it like that. If you want to graph this, and you don't want to actually have to make an XY chart or think about it, you can just flip the points around. So what was this point? This is the point, oh man, I didn't make enough lines on here. This is the point 0, 9. This is the point 1, 10. If those are on my function, I know that on the inverse it just has to be flipped around. Right? That's what's super great about inverses. So I didn't make this one. Let me make this go like this. 1, 2, 3, 4, 5, 6. Or I could have went back and just put little lines in there. That would have been fun. So I know that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then at 10, 1, it's going to flip, and it's going to go like that. And it seems very, very small, but it is reflecting about that line. If you took this and you flipped it over, it's a little squished in there, but it is reflecting about that line. And so when you have to graph these, if you just graph one of them and flip the points over, then you'll get the inverse as well. One more that we don't have to graph is those darn fraction ones that they like to give us just because it's a little bit trickier with the algebra. And again, what makes it harder with the fractions is the algebra that comes with it. So the last part of the homework says find the inverse. It doesn't say do not graph, but it doesn't say to graph, so I just like to remind you that you don't have to graph these. In Algebra 2, you never found an inverse of something like this. If you took pre-calculus, we did find an inverse of something like this. People didn't like it very much. Probably the most missed question on the test over inverses that we took. Because it's a little tricky, because what happens when you mix these up is now you have a y on the top and a y on the bottom, right? Like when I do this, I automatically say, well, that's going to be y equals, so then I'm going to switch it, and that's going to become x equals 2y minus 3 over y plus 4. Once you do one of these, oh my gosh. It's terrible for someone listening to this. They're always the same. If you have a y on the top and a y on the bottom, the algebra is the same every time. It's just remembering what to do. Step 1, how are you going to get that y plus 4 out of the bottom of that fraction? What? Can I multiply both sides by y plus 4? That'll cancel that out. So if I distribute over here, I get x times y plus 4x equals 2y minus 3. So that looks a little better because now we at least don't have a fraction. But again, what's weird about it is you have y's, like two different things that have y's on them, which means you cannot just say, oh, I'm going to subtract 4x and divide by x. That'll be good, because you'll still have a y over here. You can't just get this y by itself, because you'll still have a y over here. So what you have to do is get your y's together on one side and everything else on the other side, and then maybe the algebra will come to you here. So get your y's together, which means I'm going to subtract 2y over here, and I'm going to subtract 4x to the other side. Now remember our rules with algebra that we should know. There's no way that I can put x, y, and 2y together, like combine them. Like I have to just write that as x times y minus 2y. And then over here, I would have, I don't even know how you want to write it, but negative 3 minus 4x. I need to separate this y from this. You know what I could do to get that y away from those other numbers? Yeah, I could just factor it out. So if I factored this y out, I would have y times x minus 2 equals negative 3 minus 4x. And then hopefully you can see it now. You can see the light at the end of the tunnel here. To get y by itself, now that this is multiplication, can you just divide x minus 2 over to the other side? Which means that my inverse is negative 3 minus 4x over x minus 2. There is no shortcut to that. There's no shortcut to say, looking at that you would know this is the inverse. It's just an algebra. The same thing with the ones with the fractions yesterday. They weren't terrible. It's just the algebra to go with it. And every single time that you have a rational function like that, it's just algebra. The good news is they don't make you graph that because you have to do the asymptotes and, horizontal asymptotes and vertical asymptotes and all that stuff that we just did on Unit 3 test. We already tested over graphing that. We don't have to graph them. We just have to be able to find the inverse. I believe on the homework for this one, it says verify algebraically that they're inverses. You don't have to just find it. Okay? This is your homework. 45, 46, those are for the graph ones. 48 is the graph one. And then starting with 51 through 60, that's where they say find the inverse and graph. And then 63 and 66 this Friday. I know people think for some reason still, although you're seniors and you've had homework on Friday from me for a long time, if you hadn't before, that you don't have to do homework on Friday. You do. We'll have a homework quiz on Monday. We're gonna have a quiz on Tuesday.